Okay, well, the purpose of this video is to see how we can take some example programs and then turn them into motor control for a small robot. So I've been in search of a $20 robot for a long time for educational purposes, and I've finally found it. So we're going to start off, I'm just using a cardboard box as a chassis, and then I have two micro servos. This is part of the secret of the $20 robot. So I was able to find micro servos that came with wheels and for I think $2.50 each. And then I have an Arduino over here that my friend Terry sells at his website called Your Arduino. And it's trying to focus a little bit. There we go. And we can get these for about $12. Right. So all together we're up to like $17. Great. So with these micro servos, if I was trying to use motors to drive this robot, then I would have to have a separate motor controller. So that makes it necessarily more complicated. And this board is pretty tough. It's got a more vigorous voltage regulator than the standard Uno. So it can take quite a bit of current. So I can run two servos at the same time. That's the main idea. All right, now I just want to check my communication first. So I'm going to go take a look at the Arduino IDE. And the first thing that we'll do is we'll take a look at what port I'm pointing at. So that's good news. It says COM6, so that's great. So we'll select that. And then I just want to upload Blink. In case you're wondering where to get this program from, you go to File, Examples, go to Basics, and Blink. So the checkbox is for compiling, so that's checking spelling, and it's probably, it's a really good checker. It'll find the smallest mistake you can possibly make. Like for instance, in this void setup, if I left out the semicolon and I tried to compile again, it would say, aha, I saw that. You notice that expected semicolon before brace. So yeah, that example, that helped out nicely. So I'll try and check spelling again. Check spelling, check syntax. So in this example in Blink, a lot of comments, but it's a very useful program. And then let's take a look at what it's supposed to do first. So under void setup, which as we know only runs once, let's set the pin mode LED built in, which is also pin 13 as an output. So digital write, built-in LED high, it'll turn the LED on. Wait for 1000 milliseconds or 1 second, and then turn it low. Wait for 1 second. So this is going to blink the LED on and off with a 50% duty cycle and at a 2-second period. So I'm going to go ahead and upload this, and then we'll stop share and take a look at the board. And you can see that the LED is blinking. Okay. So now the next step is we'd like to use one of the example programs again to get one of these servos moving. And in order to do that, we're going to go back to the Arduino IDE. And now we're going to get a different example program. File, examples, and I'm going to go down here to servo. Now, if you don't have servo available, then that means that you need to add the library, the servo library, which is really easy to do. You can go up to Tools, Sketch, Include Library, Manage Libraries, And then you can type in the search right up here, you can just say servo. So servo is like a motor. And there you go. So that's it right there. So I've already installed it, and then I could update it if I want, but I don't think it's been updated recently. So we'll save on that. Okay, so once again, file, examples, servo. And then there are two programs here. One's called knob and one's called sweep. So with knob, you could use a potentiometer to set the position of the servo. With sweep, it's just going to go back and forth. So we'll go ahead and grab that. And then let's take a look at what we need to do here. So this is, it says include this library. And then we create a servo object with the name myServo. And then we're going to initialize a variable called position, POS. And then in void setup, we connect myServo to pin. So that's pin 9. All right, so I'm going to need my servo to be connected in here to pin 9. Okay, so here's what it looks like. So I'm going to start off by connecting the right servo to pin 9. And with the servos, there are 3 wires in this particular case. So brown, red, and orange. So brown is ground, red is power, and then orange is signal. Now, the nice thing about Terry's board is that he's broken out pins, header pins for each pin on the Arduino. So normally, if I was going to try and do this, I'd have to have a breadboard and get some extra jumper wires, but here I can just keep it nice and easy. So the blue pins are ground, the red pins are +5, and then the yellow pins are signal. So I want to just match those up. So brown, and I want pin 9. So I'm going to count backward. This is 13, 12, 11, 13, 12, 11, 10, 9. And the servos twitch a little bit when they get power. I really should have unplugged this first when I'm making connections like that. So sorry, this is bad form, but just to expedite things. Okay, I'm going to go back to share screen. And now we're going to take a look at sweep. And then we'll go ahead and upload that. I don't really have to check this. This is an example program. Yeah, well, what the heck, let's do it anyway. Right, so if you don't have any errors, it should come back pretty quickly saying done compiling. If you do have errors, it takes a little bit longer because the IDE is trying to figure out what your error is. So I'm going to upload this, and you can see my servo is starting to move and making a funny little noise. Okay, good. Now I have a problem because it looks like I didn't tighten up the screw all the way. So I'm going to have to go in and fix that. Okay, so I fixed that. And I'll go and upload the program. You can tell by the blinking LED that when I was looking to adjust the tightness of the screw on that micro servo, that I wanted to disable the servo and stop it from moving. So I just uploaded blank, and that put a stop to it. So here we go. So now I'll have to upload this code again for sweep. We upload that. Okay, good. Now we can go take a look at the behavior. Okay, so you can see that the motor runs in one direction and then it runs in the other. So I'm going to see if I can't make it stop, because that would be great. This little motor whining kind of drives me crazy. So we'll go back here to sweep and just take a look at what's happening with the code. So when I go down here, void setup, right, attach my servo to 9, and then here's where the sweeping happens. So we have a for loop that goes from 0 to 180. in increments of 1. And then we write that position to the servo. So it's going to go to 0 degrees, and then 1 degree, 2 degrees, and so on up to 180. And there's a delay in here to just give a little bit of time for the servo to actually get to that position. But it's 15 milliseconds, so you hardly notice it. Looks like continuous motion. And then here's a countdown from 180 back down to 0. Okay, well, I'm trying to get this continuous servo to stop. So I'm just going to put in 89 here, because I think the stop position is going to be around 90. Then we'll go over here and put in 91. Okay, and then we'll flip that around. We'll go down here and put in 91 to 89. So this will be a much more limited motion and might not even move at all. All right, so let's go ahead and check for syntax. Always a good idea as you make changes incrementally to just check syntax so you don't have to debug too many errors at the same time. And then we'll upload. Oh, it's gotten quieter. So yeah, it's stopped moving. Okay, well that's good. So let's go ahead and make some adjustments to this program. I'm going to start off and give this a different name. So I'm going to try drive program 1. I appreciate the comments. It's a nice way to sort of like give credit where credit's due, but I'm going to start. Everybody knows what sweep does anyway. So I'm going to go ahead. I have to keep the include library, and then instead of servo my servo, I'm going to go write servo. And then when we're using file names, this is essentially C. A nice convention if you're using 2-word names is to not use spaces in between them, but then put in capital letters so that they're easier to read. Okay, so create servo to control a servo. Great, so I don't really need that. We're gonna just kind of clean this up a little bit. Okay, so position. So this was used with just one servo. I need more than that. So I'm going to go write POS. Whoops. Going to get down there first. Okay, write POS equals 0. But I'm going to change it. I'm going to say 90. Because that's not moving then. Right? So then everywhere it says my servo, I need to change that to write servo. And attach 9, that sounds good. Go down here, and instead of my servo, once again, it'll be write servo. And instead of looping, I just want to set it to a particular position. So we're kind of testing here, right? So the syntax that I really want is write servo dot write. So I'm going to get rid of the looping. And I'll include the delay statement. I'll actually make the delay statement a little bit longer. So I'm going to make it delay 200. Because now I can just test different positions. And then we'll give it time to get there. Okay, so that's good. A really useful command is Control T, and that just goes through and sets all the tabs for you. So you notice that if if I had put in an extra brace here by accident and I hit Control T, then that didn't really show me anything. Oh, I know it. So let's suppose I go in here, I put a tab in, and I put in an extra brace here, and I go to Control T. So that's going to automatically take my tab out because it's trying to show me politely that I have a brace, open brace here and a closed brace here, and I don't need this one. So the Control T is a really useful tool. All right, so this is not going to be that exciting because it's just going to, servo should not move really. Oops, and I got an error. Right servo not declared. Let's see. POS, right. So I had to change the variable name too to be right. POS. Okay, good one. Let's check spelling again. Okay, all done. That's great. Okay, well, let's go ahead and upload this. And this is not going to be very exciting. So servo twitches, but it's not moving. All right, so now I want to test again, and I want to give it a different value. So let's go ahead and try to, let's say 100. And then I'm going to upload that. Okay, I'm going to stop share now so you can see my robot. It's actually turning, it's moving backward. So that's the important reason why we just test. So I'm going to go back and do another test. So I know 100 makes it go backward. Because forward and backward is all relative. Because if I flipped it over and I put the servo on the other side, then that would be going forward. So I'm just trying to figure out what's forward and what's backward. Okay, what about 80? So let's upload that. And now my servo is going forward, which is great. I'm going to change that to 70 and see if it goes any faster. Oh, it's humming. So the 90 means it doesn't move at all. And 80 made it go forward at a moderate speed, and then 70 makes it really hum. Actually, I made it 780. Let's try this again. Let's upload 70 again. Yeah, so it's a moderate speed. I like 80 though, because you can always play around with these speeds later. But I'm going to have an application that I want to go too fast. Okay, good. So now what I'd like to do is have it stop, because then I'm going to make some changes to the code. So I want two servos, servo, left servo, and semicolon to end that statement. And then in setup, I'm going to copy this and paste, and then we'll change this to left servo. And we'll attach it to pin 10. Now the use of the pins is important because only 6 pins can do servos. They're the pins that are labeled as pulse width modulation, and they are, if memory serves me right, 3, 5, 3, 5, 6, and then 9, 10, 11. So this one should work. And now I'd like to do the same thing. So I'd like to get another variable for left position. And we'll put that in here. So we'll change the name. Okay, and so we've attached that. Now void loop, that's the part that keeps running over and over again. And then I'm going to change this to, or I'm going to copy it rather. Really don't need the comments, but that's okay. And of course, we'll change right to left again. But this is a nice way of creating your code because we have syntax that we know is correct, and we're just copying it and getting it to the right spot. So left POS. All right, so these are both 90, which means that they should not move at all. So we'll go ahead and do that. So I'm going to upload. Again, not very exciting. Okay, and nothing happens. That sounds good. Now, one thing, so that's in pin 10, but we need to plug in the servo in pin 10. So I chose 10 because it's right next to 9. It's easy for me to see. Oh, but you can see from the shadow right here that it's creeping forward a little bit. Ah, no, it's kind of twitching a little bit. So all the servos are a little bit different. So to find the dead spot, it actually, you have to check it. So it's creeping forward a little bit. So I'm just going to make a guess. I'm going to just guess that I'm trying to find the servo value that's going to get it to stop. And so that's with the left one. So I'm gonna guess on the high side. So let's try 91 and upload. It's going faster. So let's try 89. Okay, now both are stopped. And when I was at 91, that was going forward. Okay, so now in the next step, I can actually, I can change these numbers. So let's do this. Let's make a function that's called all stop. So void all stop. We start off the declaration of this function with void because it doesn't return a value. So open brace, and then you can see the IDE is put in a closed brace for me, which is very nice. Okay, so in the function all stop, we're going to take these two, and I'm just going to get rid of these comments. So for this particular set of servos, it's going to stop when these two conditions are met. So void all stop. So I'm going to copy and paste this into all stop. And Control T to take care of the formatting. Get an extra space in here. Okay, so I can call this function all stop now. I can call it from void loop. And so actually things are going to go a lot faster now. So with all stop, I know that I'm going to give right servo a value of 90. And that'll stop it. And then I'm going to give the left servo a value of 89, and that'll stop it. Okay, good. So let's do another one that goes forward. So Control C. Whoops. So I'm going to copy this. Function and paste. And now I'm going to go through and make a function called forward. For the previous function, I said all stop because I think stop is a recognized word for Arduino. So for left servo, I know that a number bigger than 90 is going to make it go forward. So I'm going to type in 100. And then a number less than 90 will make the right servo go forward. So 80. And I can probably put some comments in here, like / less than 90 for forward. And the same thing over here for the left is that a reminder that greater than 90 for forward. Okay, let's go ahead and upload that, but I haven't called the function yet. So I'm gonna go all stop for 2 seconds. So I'll put in a delay here for 2000. Whoops. Milliseconds, and then we'll do a forward. We put open parenthesis and close parenthesis because all functions have arguments. It's just that in this case, we're not really passing any arguments to the function. So, and then of course, another delay. Because if I don't do that, if I don't hold up the program, then it's just going to go right back to all stop again. Okay, good. So let's check and see how we did. Crazy, no mistakes. Okay, let's stop the share and see what it looks like. So we should be going forward for 2 seconds. And then stopping for 2 seconds. So that looks great. All right, so let's take care of the rest. We ought to be able to go reverse. So we'll put in a function called reverse. And then do a delay for 2 seconds. And so let's go ahead and make a program or a function for reverse. So Control C, Control V. So this logic is going to switch. I want, got to be careful about this. So I want greater than 90 for reverse. And then I want down here, I want less than 90. So I'm going to put both motors in reverse. And of course, you can probably guess where we're headed with this. We're going to do two more functions after this. One is for turn right and one is for turn left. And so now I'll change those values. So we're going to go 100 and 80. Okay, let's check our syntax. Whoops. Forward, reverse. Reverse was not declared because I forgot to change the name, but down here. All right, let's check it. Done compiling, so we're going to upload. So now it should be stopped for 2 seconds. Forward for 2 seconds, backward for 2 seconds, and then stop. Forward for 2 seconds, backward for 2 seconds, and then stop for 2 seconds. Okay, well, that's good. Let's keep on trucking. We just got 2 more functions to do now. And so that we're going to do spin turns as opposed to sweep turns. So a sweep turn would be one motor is on and the other motor is stopped. And spin turns are where one motor is forward and one is backward. So let's build those really quick. I'm going to paste this twice. So we'll do right turn. And then left turn. So if I'm turning right, I'm turning to the right. So I want the right servo to go backwards. So this is correct. But then I want the left servo to go forward. So that means that this also needs to be greater than 90. Delete. So that means they're both going to be 100. And then down here for left turn, you again can probably see where we're headed with this. But they're going to both be 80 because with our left turn, we need, so with our right servo, less than 90 for forward. We love symmetry, right? So we want, if we're turning left, we want the right servo to go forward, we want the left servo to go backwards. So a number less than, right? So right servo needs the number less than 90 in order to go forward. All right, yeah. So let's go up to void loop. And then I'm just going to copy the delay command. I'm going to put that in there twice. So we'll skip a line, Control V, skip a line, Control V, and we'll go up here and type in our functions. So right turn, open, close, semicolon, left turn, because these are functions, but they don't return any arguments. So we don't send them any arguments either. Control T to clean up the spacing and keep our fingers crossed. So compiling, yep, done compiling. And let's see. So we're going to have a delay after each one. That looks good. Forward, backward, turn right, turn left. I'll stop. So it goes continuously from one motion into the other because I didn't do an all stop in between the commands to go forward, reverse, right turn, left turn. All right, well, that's it. So that's the basics of how to copy example programs and then get it to do what you want. So I'm going to go back to share screen and just run through this one more time to see what we did, and then we'll end on that screen. Up at the top, all right, we had to declare two servo objects, and we called them right servo and left servo. We didn't wind up using these declarations, but you could certainly use variables like this in the future. But now what we have after we figured out we're going to use pins 9 and 10 is that now we have a range of functions we can use to maneuver. And then you can play around with this. So, you know, see what kind of pattern, if you can move these around, you know, can you have your robot go in a square or a triangle or something like that. And so the degree to which it turns or goes forward or goes backward can be modified by changing the time, the delay. Okay, well, that's it. So in the next program, we'll see how we can modify this to use some sensors to figure out which way we're going.